Okay, hi. I'm Tyra Wang, and today I'm gonna talk about a prototype pattern named the state pattern. And this is me. My name is Tyra Wang, and my preferred pronouns is he, him, and his. And reason for take this class is to learn more about prototype and production thinking. And something interesting about me, maybe I'm now in Beijing now, so all of the classes this semester will be at night. That might be the most challenging semester in my life. Okay, so the topic is the state pattern, and one of the mechanics is using is the finite state mechanism machines, the FSM, and it comes up out of a branch of computer science called automata theory, whose family of data structures also includes the famous Turing machine. Actually, in this chapter, it's about using the FSM to adjust the modes or the status of the character or of the comments. This is the sample from the book. Actually, it's a series of movement of a heroine, a just a character. Yeah, it's like standing and press down, it ducking, and release it, it will recover standing again. And as pressing B, it will jump and while jumping, press down is diving. And when it's good to use, in these situations, you are good to use the state machine. First is you have a fixed set of states that the machine can be in. The second one is the machine can only be one state at a time. A character may not be able to do two things simultaneously. Preventing that is one reason we are going to use an FSM. And there will be a sequence of inputs of events is sent to the machine, just like a roll button presses and releases. And each state has a set of transitions, each associated with an input and pointing to a state. When an input comes in, if it matches a transition for the current state, the machine changes to the state that transition points to. Yeah, traditionally, we have used the enum pattern and use a switch pattern to collaborate with it. And it's mainly focused on the state rather than input for the early prototypes. With the switch pattern and the enum settings, we can switch different modes and get input. Then we switch to another mode. And this state pattern here, we are not using enum pattern anymore, but we are using uh, different classes and a state machine. Thus, we are using different subblock classes to define different states, and we use a state machine as a superclass for disposal. And there are different functions and updates. We use these subclasses to do the update and use the state machine to change our state to deal with them. Here is an example for my tutorial, but it might not be so corresponding to the chapter because I can't understand the JavaScript. So I just get reference to these squirty codes on YouTube tutorial that helps me a lot, and I just made my version at the basic of this one. So the main character will have three states: moving, rotating, and chasing. He will just change between those three states, and this might be just my analysis. um, the state machine will set the different states, and there is this different subclasses will be connected to the superclass state, and with the states there will be an update to the main controller. Actually, it should be in the state machine, and here is the example. Oh, it's not playing. See, actually, when the character is moving, it just move forward, and if it detects any barriers, it will rotate to change direction. Actually, but as it detects the enemy, it will chase the enemy and try to kill it. But due to some issues, it may not work well here because yeah, just there are some problem with the collider. I forgot how to do that, and um, actually, actually, yeah, it kills an enemy. It finds the enemy, and I'm not sure. I think the chasing state should be working, but due to the problem of the collider, I set it as a trigger, but it still has collision. I think it should be, yeah, kills another enemy, and it just search and move forward and well get one. It should be killed that one, but there are some problem with the collider. Yeah, and here are some script prototypes I've made, and this is the firstly we set the state machine, and we that is the main concept. We get the current state, and we have to make sure it is not now, or we will exit it and we will set it to the current value, and then we if it's not now, we will update it into the enter function. And for the super state super class, it will be a abstract class. It will assign the game object and the state machine. Actually, it's the super is the super class, and these three are three different states. They are subclasses of this one. Actually, this one is the AI controller, and we are gonna firstly assign the first state here. So we are gonna awake the state machine and assign a new moving state. Yeah, the first one is moving state, and those three will be updating each other. And this one is the first one. It will be doing a basic movement, and actually there are two extra classes, the moving setting and the detect collision, assigned to this character, and there are some fields used in here, and if it detects the block, it will um, it will switch to the rotating state, or if it detects enemy, it will switch to the chasing state. As it's in the rotating state, it will do rotation, but if it's there's no block anymore, it will return back to the moving states. And in the chasing state, it will just try to get the enemy and try to oh, detect the enemy. And if there's no enemy, it will return back to moving state. Or if it detects barrier, so it has to rotate, it will return back to the rotating state. Well, thank you. And this is my state machine prototype. And there's two references. One is the chapter by Robert, and the other one is the YouTube video I've uh, borrowed just to get reference to.